Good day, everybody. Welcome to Algebra 2. So today we're going to review for our test. Our test, I've decided, will be on Tuesday of next week. So you have basically 5 days to get yourself reviewed and prepped. I will review today, and I will review a little tomorrow, and I will give you a big fat review packet to work on between now and the test. It'll be due on the day of the test, which again is Tuesday. If you are out for some reason, I will post the PDF of this thing I'm going to hand out, the review assignment. And then everybody else will just give a piece of paper. So let's get started with our warm-up. Our warm-up today is very much an oral one. Just kind of redefining some vocab. I'm not going to do anything on the board for it, though. What's a domain, guys? What do you guys think? Answer? Love it. There you go. Something like that. All the x values for a function. That works just fine. All the x's you can plug in, all the x values for a function, anything like that. I'm not going to be too picky with vocab or anything like that. Don't sweat it. Okay, good. So domains about the x's. The following two terms in number 2 are about the y's. What's a codomain? Any remember what that is? We don't do that one too much. That's all the y's you could possibly get out. Possibly. Your range is all the y values you actually do get out. So my class, my codomain for students is all of you. I could have all of you here. It's not true today. There's many of you absent. My range, what I actually did get out, was different than my codomain right there. All right. Something is 1-to-1 if it passes what test? Horizontal line test. That's your quick cheat sheet to remember what that is. It's got a really fancy definition. Basically, it means for every number that you come out, there's only one number you could have put in to get it. But graphically, the easiest way to understand that easily is just to do the horizontal line test and see if it passes. If it passes and it only hits the graph in one spot, for every horizontal line, it's 1-to-1. If it doesn't pass, it's not 1-to-1. Something is onto if your range is equal to your codomain. That's the answer for that one. So if I actually do get out everything I could get out, that is what onto is. This is kind of like your review right here, but we'll go more in depth as we go along. What's a continuous function? Long story short, it's something you can draw without picking up your pencil. So not something nice and smooth you can draw. You don't pick it up. There's no graphs blowing up. There's no holes. There's no gaps. Nice and smooth and continuous. How do you find the intercepts of a graph based on its equation? Well, if you're trying to find a y-intercept, anywhere on the y-axis, x is 0. So if you're trying to find a y-intercept, you plug in 0 for x. Similarly, if you're trying to find an x-intercept, you plug in 0 for y. Anywhere on the x-axis, y is 0. And that's how you guide yourself to figure out where the intercept might be with an equation.
The problems for this? Three people wrote the same problem wrong, and they all have to put the same answer.
If that keeps happening, just give it to them too.
They all put 60. I just want to see what it is.
Okay.
I keep getting it wrong.
Even function is something that's symmetric across the y-axis. If you take a graph and do a horizontal reflection, same thing. Flip it horizontally over the y-axis, and it's the same on both sides. Then it is even. That's a special case of a line symmetry. On the other hand, if you flip something over the origin, that's point symmetry. You take any point on the graph and flip it directly over the origin. It's the same on the other side. That would be an odd function. So an even function is symmetric across the y-axis. And an odd function is symmetric across the origin. Lastly, You got extrema. Extrema, kind of the word extreme comes to mind. It is an extreme on a graph. It's a hump. It's a max or a min. A local max or min means that locally, close to that point, it's the highest or the lowest spot around there. Everything is local. That's what a hump is. You look at a hump, and if it's the top of a hump, well, then it's the highest spot around there. A global extrema, min or max, is when it's the highest or lowest spot everywhere on the graph. Throughout its entire domain, the highest spot ever or the lowest spot ever as well. Now, that's a lot of buzzwords there, right there. And I'd say that this is probably, at least a third or half of your test right here is just understanding these concepts. So let's go ahead and dive in with some learning goals. And then we will start doing a proper review. We'll go through all the concepts pretty darn quick. Here's your LGs. After we go through the concepts, we'll do some quick examples, and I do mean pretty quick. That's a problem. This is just to refresh your mind on what we were even talking about. It's been a while. Once you get the review assignment handed out, that's really where you're going to need to start buckling down and studying, because that's going to be the format of the test and the kinds of questions on the test. And I want you to ask me lots of questions as you're doing it. That way you're totally prepared for it. All right. Let's get going. Here we go. Homework 1.7 is due today, though. That's the last of the online stuff for the unit, so make sure that's turned in by the end of the day. The last one's called Homework 1.8. I'll just hand that out right now. Why not? We might go over a problem or two while we're reviewing. Get some freebies for you. It's big and fat and thick. Don't let it scare you, though. A lot of it's pictures and graphs that just space to work and things like that. Although it does have a lot of problems, because there's a lot of stuff in this unit. I really wish I could have trimmed it down more, but just so many ideas to cover, so many things that we talked about. Crazy. This is due on Tuesday, homework 1.8. You have 5 days for it. You should try probably to get the first half of it done or so, by Friday or maybe Saturday or something like that, because we're going to review the first half today, so really should be able to get it done in theory. Test is Tuesday. All right, here we go with our review. Shouldn't have to write anything down because it's the exact same notes you had before. First thing we talked about were functions and continuity. So you got yourself a domain and a codomain and all that kind of stuff. I encourage everybody who is remote to follow along with the up-to-date PDF. I'm going to go to the camera, and that way we can do things on the board. And, well, you guys, I'm going to freeze it. All right. So domain, all the X values you're allowed to have. Codomain, all the Y values you might get out, and all the Y values you do get out is called your range right there. 1-to-1, does it pass the test? Now let's just go ahead and look at one of your problems, okay? That's probably the easiest way to review. Which one do you feel like? Look at the front page. Which one looks the hardest for you? Which one looks the hardest on your review? I'll do your hardest one. Or we'll just do one. Okay, we'll do number 1. Number 1, if you look at the graph on number 1, it looks like this kind of curvy thing, and it comes down, just stops at a point. Not that it doesn't look exactly like that, and something like that. This is number 1. Now, how are you supposed to write things? This is what I really want you guys to get used to, okay? Because you don't need boxes to click or anything like that, so let's focus up. Domain is all the X values I can have, correct? So I'm going to walk along, and these tick marks, this is at -1 on the X's and +1 on the X's. So always go left to right. Here we go. We're coming in from -infinity, correct? Does the graph exist over here? The answer is yes. Tell me what X value it stops existing at, right at -1, correct? Now, this is a closed circle on the graph. Does that mean I include that point? Yes, I do. So you want to write -infinity to -1 with a bracket. Brackets and parentheses are probably the number 1 thing you've got to worry about when you're doing this kind of stuff. That's a bracket because that's a filled-in hole. It does exist at x equals -1. Then the graph just disappears. It doesn't even exist in between here, these x's, right? But then it starts existing again, right, at 1. And again, there's a closed circle, so you include it. And it keeps existing all the way to the right to infinity. So you put a u, remember that union thing? That was when you glue two pieces together. And you have a bracket 1 to infinity right there. So looking at this graph makes perfect sense why that's the domain right there. Then they ask you for the range. Range is about all the y values that exist. So you always want to go from the negative to the positive, left to right, bottom to up to top. So does it go down here? Yeah, it goes from negative infinity all the way up to, does it hit y equals 0? Yeah. And then even though it's on a different piece, it still goes up, doesn't it? So doesn't it cover everything? Yeah, everything from negative infinity up to positive infinity. All y values are hit at some point by some piece of my graph. Everything's hit. Now they ask 1 to 1, and they got a yes and a no, y and an n. So you got to circle 1 on that one. Is it 1 to 1? That's the one where you do the test of the horizontal line test. Now, does it hit only one spot? One spot. One spot. What about right here? That fails, doesn't it? So what do you circle for 1 to 1? No, this is not 1 to 1, unfortunately. Is it onto? Onto means what? Onto means that your range and your codomain are the same. Now, if you look in the directions up in the very top, the last sentence in the direction says, for all functions, the codomain is negative infinity to infinity. That's the same as our range, correct? So for onto, you circle yes, and we're done with that one. Then you got something that says continuous. Continuous means I could draw without picking my pencil, correct? Could you draw this without picking up your pencil? No, so you circle no. This is not continuous. It's not one big smooth thing. Circle no for that. And then the last two things on the problem are these limit things. They're talking about the end behavior. Remember that stuff? What happens if I go really far to the left or really far to the right? So the first one says limit as x goes to negative infinity. That just means as I go to the left, what does this thing do? And it goes up to how far? Infinity. So you actually write in the infinity symbol right there. It goes up to infinity. The other one, limit as x goes to positive infinity, means we're going to the right, correct? And if you look on the graph, as you go to the right, it actually goes down to negative infinity. So that answer would be negative infinity right there. And that's essentially the entire first page. It's just looking at those kind of things and going through one by one and reading off pieces where it exists or it doesn't exist. I don't want to go too fast. I don't want to go too slow. Do you guys need more examples of that? Or do you think you have the gist? Silence equals, I don't know what that means, but it means I don't do more. All right. So let's get back to it then. So that's kind of the first page. Why don't you go and just turn the page? Let's see what else is kind of floating around here. Next page, 5 and 6 and all that kind of stuff. It's just about graphing functions and figuring out where they're increasing and decreasing and stuff like that. So this is very much about linearity and lines and stuff like that. These are all linear. Well, that's bottom one's not, but it doesn't matter. So for this one, again, just graphing things in general, you know, linear means line, right? So it might be a line. It might be something different. You don't know what's going to happen. But this is the main thing to focus on. How do you find intercepts? And we said that in the warm-up. If you're trying to find x-intercept, the key thing is set y equal to 0, correct? And if you're trying to find x-intercept, the other thing is to put y equals to 0. So basically, whatever intercept you're trying to find, the other one is 0. Cool? All right. Now, there's also symmetries that were talked about in this kind of thing. There's even and odd symmetry. There's specifically line and point. I'm not going to have that on the test anywhere in this packet, but I'm going to have these two, even and odd. Very much a visual thing right here. Even function looks the same on both sides. And an odd function, if you take any point and flipped it over the origin, so here's a point, and I don't know, I lost my place. If I have a point right here and I flip it over the origin, it's the same there. Basically, it's the same thing as if you flip it upside down. You got a calculator? If you want to check something's odd real quick, just graph it, take your calculator, flip it upside down. If it's the exact same picture, it's odd. That's cute to know too. Okay, so that's kind of all the symmetries here. And then I also talk about increasing and decreasing a little bit. I'll get to that in a minute, though. Let's go and do a problem, 5 or 6. Which one do I feel like? We'll do the easy one, 5. All right, number 5. Graph each function in terms of its any even or odd symmetries. Then use the equation for the function along with its graph and your calculator to find any x and y intercepts. So I'm saying you can use your calculator, right? You might want to graph things when I say you can use a calculator. Although, in theory, you shouldn't need the stupid thing. You should be able to do anything from scratch, no matter what they give you. So let's try to do it from scratch and see if we can figure it out based on that. All right, here we go. Number 5. Graph is 2x. So what's a graph of 2x look like? It's a boring line, right? There's no y-intercept, so it's going to cross at the origin. The slope is 2, so it's going to go over 1, up 2, over 1, up 2. Something like this is what I would need to put on my graph right there. Very first thing it asks for is it even? Is it odd? It could be both, or it can't be both. It could be one or the other, or neither. So it's possible to put a yes and a no, or a no and a yes, or a no and a no. Okay, based on our definitions, even means if you flip it over the y-axis, it's the same. Is that true? If I flip it over the y-axis, it's the same on both sides? If I flip this over here, there's no graph here, right? So that one's not even. So for even, you write no. It's not the exact same thing. If I flip it over, I don't have the same graph anymore. It's different. Odd means it's symmetric to the origin. So if I take any point on my graph and I flip it directly over the origin, do I get another point on my graph? Yes, I do. This one is, in fact, odd, so write yes. As a secondary note, remember that these words have meanings. It's even because it's even built out of even exponents, or it's odd if it's only built out of odd exponents. The only exponent I see is x to the first, which is odd, right? So the equation saying it's odd, the graph saying it's odd, as they both should because of the same thing. X-intercepts, where's it cross the x-axis? Now it says intercepts with a parenthesis in S. That means there might be multiples, there might be 1. In this case, how many spots does it cross the x-axis at? Just 1 right here, right? The origin, 0, 0. So for x-intercept, for one of them, put 0, 0, and the other 2 you leave blank because there aren't any more. I'm not going to tell you how many there are. That's why I give you like 3 slots or something like that, because there could be lots. I'm not going to put 1 slot because there's 1 answer, or 2 slots because there's 2 answers. I'm going to make you, oh, maybe there's 3, but there's just 1. You leave it like that. Y-intercept. There will always be only one of those. And again, where's across the y-axis? At the y value of 0, right? So your y-intercept is also 0, 0 in this case. Score. Then they got increasing and decreasing. And this is where you're just walking along the graph and you're reading where it's going up and going down. Now, we picked a very boring example. We wanted to pick the boring one. So what's it doing? It's always going up. It's always increasing everywhere from, it's always at the x's, from negative infinity until infinity. That's what I'm going to write. From negative infinity to infinity, from all the way from the left to the right, this thing is always just shooting up and going up. Increasing, increasing, increasing. Does the graph ever decrease? No. So you can either leave that blank or put a slash through it or not applicable or whatever the heck you want. It doesn't really matter. Just don't put an answer. If you put an answer, then you're going to tell me, okay, it's decreasing somewhere. And this got a slot for Extrema. Extrema is just a fancy word for what? Mins and maxes and humps, right? Any humps? Nope. So again, same kind of thing. You just put a slash through it, and you're good right there. What if there was an extrema? We're not the problem, but what if there was an extrema, say, right there at 2, 4? If there was an extrema, what would you write? Well, first of all, what kind of extrema is this? Is it a min or a max? It's a max, check. Is it a local? What do you always say for local? Yes, it is. Is it a global? I didn't quite draw. Let's just say this goes down forever, something like that. Is that a global max? Yes. So if you saw something like this on your graph, you'd have to go right. There's a local and global max. And you need to tell me where it's at, too. At what x value? At x is 2, right? So it's a lot to write for the slot that says extrema. You got to tell me if it's local, if it's global, if it's a min, or if it's a max, and where it is. So read the directions very carefully on that. Please use your calculator on that, okay? I put a tutorial on there about how to find extrema. Did you watch that one? If you didn't, go watch it. There's a whole section about calculator tutorials. If you're guessing, it ain't going to work. If the real function you graph, this happens at 1.98, and you're eyeballing it, and you're saying, oh, I'm moving my cursor, here I am, here I am, here I am. Oh, it's pretty close to 2, and you write down 2. Am I going to give you full credit? No, because you're just guessing. Don't guess. Remember the second calc thing? Second calc, max, find a left bound right, find a right bound correct, and then it knows where to look, and it'll zero in and tell you exactly where the extrema is. So you need to learn that skill, because guessing is not going to fly. Feel okay about that stuff? Well, let's keep going then. So that's even and odd, extrema, and all that good stuff. Of course, you got end behavior. We already kind of talked about that. What happens on the ends of something. So for this particular graph, here's how I'm going to write it. On your test, it's going to say limit as x goes to negative infinity of whatever the heck we're talking about. What's the answer for this problem? What does it do on the left? It goes down, right? To negative infinity. And then if they happen to say as x goes to positive infinity, positives are to the right. And as I go to the right in this graph, it still goes down to negative infinity. So we're just saying what happens on the ends. And it is possible it levels off. Maybe here's 6. And your graph just slowly levels off to 6. In this case, what will be your end behavior on the right? It's approaching, well, 6, right? So it's possible it doesn't blow up. Usually it does. Usually it just gets really high or really low or something like that, but it could level off to something. What if the graph just doesn't exist? What if it just stops? Like right here. Can I even talk about the end behavior on the right then? No. If this happened, and this was a slot, you would either, again, put like a slash or a not applicable or something, because we're talking about going way off on the right, like, and way off on the left. And if it doesn't even exist way over there, then who cares? All right, let's see. Let's do something 10 through 13. Pick a number 10 through 13. This is a good one. Because also, it's not just about decoding it from a graph. Here's a graph, and I'm figuring out where it's increasing and decreasing, all that stuff. Sometimes I might give you the information. Okay, here's the domain, here's the range, here's the increase, and you go make the graph. So let's practice taking information they give us and making a graph. That was a whole section of ours. Oh, what do you feel like? 10 through 13, pick any of them. Pick a number randomly. Thanks. 12. Okay, here we go. 12. Blank graph. Here I'm starting with blank graph, and they're telling me that there is a local and global max at x equals 0. So I don't know where up and down it's going to be, but there's going to be like the highest spot ever, correct? That's what a global max means, right? All right, mental note there. It's increasing on negative infinity to 0. What's that mean? When x is from negative infinity until 0, it's increasing. And then it says it's decreasing on 0 to infinity. Now, does that make sense since there's a max here? It better, because it's got to be going up, right? Stop, and then come back down. They say, what do they say about the endpoints? They say as you go to the left, as x goes to negative infinity, they say the function goes to negative infinity. So on this side, it's going to go down. They say as x goes to infinity, on the right, it levels off to 4. So let's see what happens. It's got to level off to 4, right? 1, 2, 3, 4. I'm going to draw a little dashed line just to say, hey, this is where it's going to level off to. You don't have to do that, but I'm going to do it just so I know where 4 is. Here's 4. And we know eventually over here it has to level off to this, correct? Also, it's got to go up, have a max height right here, and then go back down. So maybe something like this. Would this work? How about that? Does that work? Is there a local and global max at x equals 0? I'm just going through my conditions. Is there? Yeah, right there. At x equals 0, there's a max. Is it increasing from negative infinity to 0? Yeah. Is it decreasing from 0 to infinity? Yeah, this is going down. On the left, does it go all the way down to negative infinity? Sure. On the right, does it level up to 4? Yeah. Is this the only possible answer that could be? No. You could draw lots of other things. As long as it fits this criteria, though, that's what I'm going to be checking for. If I say there's a local global max at 0, then at 0, you better show me the highest spot on the whole graph. If I say it's increasing from negative infinity to 0, you better show it going up. If I say it's decreasing, you better show it going down. You better show it leveling off to 4 on this side and go down to negative infinity on this side, because that's what the directions say. Any picture you draw that meets that criteria would be just fine. Doesn't have to be this. Maybe it kind of comes in, does one of these things, and then stops right there, or something like that. Maybe this point is way up here for some reason. I don't know why. I mean, that could work. I mean, there's so many things you could do. As long as it's fitting the criteria, you are good on that. And that was the section we had over sketching functions from curves. And for the increasing, decreasing, you understand what they're talking about with the interval notation? When I say interval notation, I'm really saying what? Brackets and parentheses. And you're always telling me the x values where things are occurring at, okay? Increasing, decreasing, from x is this to x is that, it's increasing, then from x is this, from x to that, it's decreasing. Where's the extrema at? There's a local max at x equals this or something like that. Very rarely am I going to ask you what the y value is, because if you know where the x is, you can just plug it into the equation and get the y if you want. So knowing where the x's are is what's very, very important. I think that's good enough for the first half of the review. You guys got any questions over any of that stuff? Seriously. Nothing. All right. Well, your goal probably, based on today's lesson, is to get through problems, probably at least through 13 today. Okay? You have work time. You have lots of time, though. So if you get stuck on something, come ask me questions. If you don't get through them all, don't beat yourself up, but try to pace yourself accordingly. It's a fat packet, and you have till Tuesday, so I would strongly advise you do a little bit every day and make sure you're on task. All right, that's it, guys. Thank you much.
Okay, I have some questions on stuff that I was grading.